getting onto integration by parts. So this one is kind of typically regarded as like um, the trickiest part of integration. Um, so yeah, it takes a lot of practice to kind of get used to integration by parts and get used to using it in a more efficient way, because a lot of the time, once you do learn integration by parts, or at least for me it was this way, when you get to a complex integral, you'll kind of look at it straight away and be like, I don't know what to do with that. It's probably integration by parts. A lot of the time it is, but you do actually need to learn the nuances of integration by parts, because sometimes you look at a complex question, you think it's integration by parts, and it actually isn't. And then you kind of go barking up the tree for a long while. So we're going to go over what it is, when to use it, how to kind of tell when to use it, and also like some complex situations in which you can use it, and also some tips for like questions in general. Okay, the formula for integration by parts is on your formula sheet. It isn't written like this, I don't believe. It is written in like a more complex format, but this is how I choose to write it because it's like more easily understandable. Um, and you're going to use it when you have the product of two functions, and the derivative of one would cancel the bad part of the integral of the other, right? So in this case here, we have two functions, and as we'll go through in a second, the bad part of one of these will cancel the integral of the other. And what I mean by that is that if you integrate one of these functions, it's going to cancel um, it's going to cancel the other part that you don't want in the integral, because up here, of course, we're going to integrate, right? And we'll get into this in a second. But the steps are, firstly, to assign each function as u or v, and then to derive u and integrate v, and then apply the formula. So what we have here is, in our formula, we have the integral of u and v dash. So what we're kind of saying is that in our integral, one of the functions is going to be u, and one of them is going to be v dash. And then in our formula, we need v, so we need to integrate this v dash to get to v, and we need to derive u to apply u dash in our formula here. So what we want to do is we want to select u and v, which one we pick is u and v, strategically, so that we can cancel some things out and make things a little bit easier for ourselves. Now, there are a few different kind of tips and tricks for integration by parts, or like kind of a few different things to remember that will help you to apply the rule. The first thing that is kind of usually taught to begin with integration by parts, is if you have a product where one of the terms is a polynomial and one of the terms is like some other function, what you can do is you can apply integration by parts so that u is the polynomial, because as you keep applying the formula, because you keep deriving the polynomial, it will reduce in power. We'll go over an example of this in a second to better understand it. But yeah, a simple rule is if you have a product of a polynomial and some other function, typically you let u equal the polynomial and then apply integration by parts multiple times until the polynomial kind of differentiates down. So there are a few other tips which I believe are on in a few slides time. So we'll go over them then, so you guys have like them in writing. But yeah, that's like the most typical one. The other thing as well to take note of is with integration by parts, like have a look at, if you're doing an exam, have a look at how many marks the question is worth. So if you have a lower mark question, you wouldn't be expected to integrate one part being V if it's too difficult. And if that's the case, then if it's a lower mark question, then probably don't do it. So what I'm talking about is a perfect example of this is if you had x, ln x, right? This is a more complex example, but say you're picking which function is going to be u and which one is going to be v. Straight off the bat, if this was only worth like 4 marks, you know it's probably going to be like a little bit of an easy way out, right? It's not going to be like a massive question. So because of that, it's unlikely that the thing you want to be v is going to be ln x because we don't have a formula for integrating ln x. So that means you have to do some other form of integration, some other method that we've learned to integrate this as a subsection of already doing integration by parts. And because of that, it's unlikely that this is going to be the thing that you have to integrate. However, if you get to like an 8-mark question, throw that assumption out the window. All I'm saying is if you have like a low mark question, it's usually going to be like the easiest option available to you. Don't try to overcomplicate it. And that really helps when you're choosing which part is U and which part is V. Kind of think, if it's a low mark question, which one is going to be easier for me to do? Not always, but as a general rule. Okay, let's get into an example of integration by parts. And after that, I think we actually have like 2 or 3 slides of my tips for complex questions on integration by parts. So this example here is pretty simple. The first thing that we need to do is, as I said, we need to choose which method of integration to use. Of course, we already know that this is in the integration by parts section, but if you just came across this question in the exam, how would you know that we need to do integration by parts? The first thing that you could recognize is firstly that the two parts of our function, the derivative of one isn't going to cancel the other because the derivative of x is 1, so it's not going to cancel any other x. We can't really use trig identities because we already have a product of x and cos. So even if we substitute something in here for cos, we're still going to be left with like, something in terms of like sine squared, blah, 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 blah. We're going to have some other trig function in here. And so we're still going to have a product of x and a trig function. So that's not really viable either. In this situation, we've kind of ruled everything out, except for integration by parts. So how do we know that we should use integration by parts? What we need to recognize is that the derivative of 1 or the integral of 1, and by 1 I mean like one of the functions. So the integral of one of the functions or the derivative of one of the functions is going to make things easier for us because you remember our formula is uv dash equals uv, take the integral of u dash v. So we know that the derivative or the integral of one of these is going to make things easier for us. For whatever reason, the product of the integral of one and the derivative of the other is going to give us like an easy integral that we can actually find. So, what I recognize here is that the derivative of x is 1, and the derivative of cos x is negative sine x. The integral of cos x is sine x, and the integral of x is half x squared. So what's going to make it simpler for us is if we let u equal x and v dash equal cos x, because then in this section of our formula here, we're going to have u dash, which is going to be 1, multiplied by v, which is going to be the integral of cos x, which is going to be sine x. And that we can integrate. So this is a classic example of when we have a polynomial multiplied by another function. Here our x is our polynomial and our other function is cos x. So what we can do is if we let u equal our polynomial, it's going to like derive down, and then in our actual integral, we have a much easier time. So let's get on to actually applying this formula. Our integral is going to be equal to u multiplied by v, which is x sine x. Take away the derivative of u dash v. So u dash is 1 and v is sine x. So this leaves us with x sine x. The integral of sine x is negative cos x. So this is going to be our integral here. Okay, awesome. So this was a simple example of integration by parts. Again, just to recap, how to know that you need to use integration by parts? You need to see if the derivative of one part of the function and the integral of the other part of the function would multiply together to give you something that you can integrate. Whether it does that by cancelling something out, or maybe the polynomial goes down, or something like that. There are a few other special scenarios, but as a general rule, that's what you need to know. Okay,